Okay, so good morning, all of you. I hope my voice is clear and the screen is visible to you guys. You remember last class we have been talking about what's our last class we have been talking about JVM architecture method area. Okay, we have discussed about this JVM architecture method area, and I told you inside the method area, that is the runtime data areas. I told you we have five sections. Have a look once again in the runtime data areas. The total memory is divided into what? Five parts, five sections. The first part is what? The first part is method area. The second part is what, sir? Heap area. Next one is what? Stack area. Next one is what? PC register. And native method stack. Native method stack. Last one is what? Native method stack. So in all these five memories, okay, if you look at this diagram, if you look at this diagram, components in JVM architecture. So now we are discussing about what? We are discussing about runtime data areas. Okay, we have already completed class loader subsystem. We have already seen how class loader subsystem working, what is delegation hierarchy algorithm, and a lot of interview questions we have seen upon this class loader subsystem. Now, last class we have completed method area. Okay, today we will discuss about heap area and stack area. Today we will discuss about heap area and stack area. So have a look. Last class we have been discussing about what's the last class. I told you that that whenever JVM makes a request to class loader subsystem for loading the dot class file into JVM memory, for loading the dot class file into JVM memory, then the class loader subsystem is responsible to load the required dot class file from different locations to what? To JVM memory. And those dot class files are dumped inside this method area. Those dot class files are dumped inside this method area. And this method area return type is class object. This method area return type is what? Class object. So last class I told you one program that, look at, import java.lang.reflect.method, and here look at, it is returning what? Class object, class.forename. Whenever we are trying to load this java.lang.object class into JVM memory dynamically, so it is returning what? Class object. And once it is returning class object, we can get the name of the class, we can get the name of the package, and we can get all the declared methods inside this object class, or whatever the class you will specify here, whatever the class name you will specify here, whatever the methods we have in that particular class, those all methods we can find out, we can extract by using this get declared methods. And then you can see its return type is what? Method is a predefined class in what? Java.lang.reflect. Okay, and now we have what, sir? For each loop for getting the complete method details. Okay, and you can count the method. Even if you want, you can count the method. Now today I'm going to discuss you what, sir? Today I'm going to discuss you heap and stack. Heap area. Okay, what is heap area? Have a look. So today two very important agenda is what? Heap area and stack area. Today two very important agenda is what? Heap area and stack area. Have a look. So listen carefully. Sir, let's assume my class test is there, and this class test is containing one main method, string of args. Listen, all of you very carefully. Sir, here let's say I have a variable called, let's say, int val is equal to 100. Okay, listen very carefully. Int val is equal to 100, and let's say uh, before this class test, we have a class, sir. We have a class employee. We have a class employees there. Okay, and now here inside this Inside this main method, I'm going to create the employee object. Have a look. Employee E1 is equal to what? New employee. Employee E1 is equal to new employee. Okay. Let's say these two quotes are there. Okay, these two quotes are there. Okay, now these two quotes are there, sir. Now, if you look at carefully, what will happen? Have a look, sir. You can see, you can see inside this main method. Inside this main method, I have a local variable called val, which is holding the value 100, and I have local variable called even. I have a local variable called even, and we have a local variable called val. Okay, so if you observe, let's say this is my stack memory. Okay, this is what, sir. This is the stack memory, stack area, stack memory. Okay, and you know, in the stack area, the first method is always what? Main. The first method is always what? Main method. So first of all, the main method will be executed. Okay, first of all, this main method will be executed. Okay, have a look, all of you. Sir, while executing this main method, what is my first variable? Look at my first variable is what? Val. My first variable is val. Okay, whose value is what? 100. Whose value is what? 100. My first variable is val, whose value is what? 100. Okay, val, whose value is 100. Now my second variable is what? If you observe, my second variable is what, sir? Even. My second variable is what? Even. But even, of course, even is a local variable. Even is a local variable. But look at this even. This even is containing object. This even is containing what? Object. Even is containing what, sir? Object. Have a look very carefully. So that means what? Objects are always created as a part of what? Stack memory, heap memory. Objects are always created as a part of what? Heap memory. So we have to create one heap memory here. Have a look. We are creating one heap memory here. Assume that it is my heap memory. Perfect. Now inside this heap memory, we have what, sir? We have an employee object. Let's say inside this heap memory, we can have a number of objects. So let's say this is the employee object. This is what? Employee object. And now this employee object is pointing by what? This employee object is referring by this even. This even is referring to this employee object. So please notice, even is created in the stack memory, in the stack area. Okay, whereas employee object is created in the heap memory or heap area. Employee object is created inside what? Heap memory or heap area. Are you getting my point? Employee objects is created inside the what? Heap memory or heap area. So this you need to concentrate. This you need to concentrate much and more. What you need to concentrate, sir? This you need to concentrate that even is a local variable, and this local variable is created inside the stack area, stack memory, but it is referring to object. It is referring to what? Employee object, and employee object is created inside what? Heap memory or heap area. Now if you look at, I want to show you with a diagram, means how to create a heap and stack diagram internally. Have a look. So let's say here I'm going to create heap area, and here what's a stack area. Okay, heap area and what? A stack area. Better to draw a particular line to differentiate. Okay, here we have what? Heap area, and here we have what? Stack area. Heap area, stack area. Have a look very carefully. Now, sir, you know very well that the first method is what? The first method executed is what? Main method. The first method is executed is what? Main method. So here, first of all, main underscore stack will be created. Try to learn the new things here. First of all, what? Main underscore stack will be created. Let me take in another color. First of all, main underscore stack will be created. Have a look. And inside this main underscore stack, you can see the first value. The first value we have what? The first value we have 100 for the variable val. For the variable val, we have first value is what? 100. So can we write val colon 100? Have a look very carefully. Val colon what's our 100? So val is a variable which is pointing to 100 value. Val is a variable which is pointing to 100 value. Now we have another variable. What is that? We have another variable even. But look at even, sir, even is pointing to an object. Even is pointing to an object. Okay, even is pointing to what? An object. Are you getting my point? Even is pointing to an object. So now objects are created as a part of heap memory. You know very well. Objects are created as a part of heap memory. So what will happen inside this heap area? Inside this heap area, the the employee object will be created. Inside this heap area, what will happen, sir? Employee object will be created. Employee object will be created. So let's assume at 1000x, at 1000x employee object is created. Employee object is created. At 1000x employee object is created, correct or not? You can see at 1000x employee object is created. And now this employee object, this 1000x employee object is pointing to what? Even variable. Even variable is pointing to this 1000x employee object, correct or not? P1 even variable is pointing to this 1000x employee object. Now what I can do, what I can write here, have a look. What I can write here, I can write here what? 1000x. Because this even look at the diagram. This even is pointing to what? This even is pointing towards our employee object. This p1 is pointing to what? Employee object, correct or not? This even is pointing to employee object created at 1000x memory inside the heap area, because objects are always created in the heap memory. Okay, methods execution always done at a stack memory. Method execution always done at a stack memory. So all the local variables are also executed as a part of stack memory. All the local variables are also executed as a part of what? Stack memory. Now look at what is the next point. Actually, I want to show you. Look at what is the next thing I want to show you. Have a look, sir. Last point. Then we will discuss the theory part, and then we will see one or two program. A very interesting program, very powerful program. Sir, let's say I'm going to write one particular statement here. Try to understand what will happen. Let's say I'm writing even is equal to new employee. Even is equal to new employee. Now what do you mean by that? If I'm writing even is equal to new employee, what do you mean by that? Look at carefully, very carefully, all of you. Even is equal to new employee, sir. What is the meaning of this line? What this line will do? I'm talking about this line. Okay, I am talking about what? I am talking about this line, sir. Even is equal to new employee, sir. What it will do? Have a look very carefully. Have a look. Even is equal to new employee, what it will do, sir? First of all, look at one employee object is creating or not. Look at the right side. Of course one employee object is going to create, no doubt about that, that yes, employee object is going to create. Employee object is going to create. So what will happen? First of all, one employee object will be created in the heap memory or not? Okay, first of all, yeah. So first of all, one employee object is created in the heap memory or not? Yes. So one employee object will be created in the heap memory. Have a look. Look at very carefully. Sir, here, let's say one more object is created, 2000x. Assume that in 2000x, one employee object is created. In 2000x, one employee object is created. Okay, in 2000x, one employee object is created. And now employee object is created means, look at here, one more employee object is created in the heap memory. In the heap memory, one more employee object is created. Okay, one more employee object is created in the heap memory. Correct or not? In the heap memory, one more employee object is created. Now, this employee object is referred by what? Look at carefully. This is the climax. What is the climax? Look at this is the employee object is created by using new keyword, and the same employee object you are assigning to even variable. Same employee object you are assigning to even variable. The type of even is employee. The type of even is employee. That means it can hold employee object. It can hold employee object. So same employee next employee object, the another employee object which we are creating by using new keyword, we are assigning to the previous even reference variable. Now what will happen? What will happen? Look at now this even which was pointing to this employee object, now this even will point to this employee object. Okay, now this even will point to this employee object, and the previous reference was deleted. The previous reference was what's are deleted. Now this is the deleted reference. Okay, now this is the deleted reference. Okay, this is the deleted reference. And what will happen in the diagram? Look at in the diagram what will happen, even which was pointing to 1000x, even which was pointing to 1000x, okay, now it is pointing to what? It is pointing to 2000x. Now it is pointing to 2000x. Okay, even which was pointing to what? 1000x, now it is pointing to 2000x. Here you can write it is pointing to 1000x, and here this one is what, sir? Pointing to 2000x. Okay, in 1000x x employee object is created, in 2000x employee object is created. So earlier E1 was pointing to 1000x employee object, now E1 is pointing to 2000x employee object. Look at note. Earlier E1 was pointing to E1 reference variable, was pointing to was pointing to 1000x employee object. Now it is pointing to, now it is pointing to 2000x employee object. Okay, so, small, brief introduction I have given to you. I hope everything is clear for you guys. A small, brief introduction I have given to you. What is stack area? What is the heap area? Okay, how heap and stack diagrams are created. Okay, we will see one or two program on this, and we will see the output of those programs. Okay, now let me go with the theory part. So, what you got from here? 2 or 3 points you got from here. So, all the methods are executed as a part of a stack memory, stack area. As for example, always our main method is what? The first method, which is going to execute, and all the objects are created as a part of what? Heap memory or heap area. All the objects are created as a part of what? Heap memory and heap area. And this is the heap and stack diagram. This is the heap and stack diagram. Okay, heap and stack diagram, where look at the stack area. A stack area will contain what? Main stack, because always the program execution begins with what? Main method. So here main stack is created. In the main method, the first variable is what? Val. Of course the first variable is args, but we are not passing here any command line argument, so that's why we are not considering it. If you are passing the command line argument, then we will consider it. Okay, so first variable is of course args, but here we are not passing any command line argument. So the val, whose value is what? 100. Then employee e1 is equal to new employee e1 is a local variable which is pointing to employee object created at 1000x. And then in the same e1 variable, I am assigning what? Another object. I'm assigning another object. So another object means what? One new object will be created in different location, because we are creating the object by using new keyword. It will always create the object in a new memory. So in a new memory at 2000x, one another employee object is created, but now the same employee object that is created at 2000x address is assigned to what? Same previous even reference variable. Same previous even reference variable. So what will happen? Look at e1 which was pointing to 1000x, now it is pointing to what? 2000x. e1 which was pointing to 1000x earlier even reference variable was pointing to 1000x employee object, now it is pointing to 2000x employee object. Perfect, let me save this. So go to 7:30 a.m. 11:04 stack and heap introduction. Sir, what to do? We call 1000x and 2000x. Is it address? Yeah, is it address? Absolutely, absolutely. It is address. You can start with any. You can start with a. You can start with any address, but I am starting with 1000x. Okay, so this 1000x is pointing to employee object, and 2000x is a address which is holding this another employee object. Why did the value change? Miss, you are telling 1000x becomes 2000x, Samir? Yeah, look at look at sir, have a look. Let's say int x is equal to 100. Int x is equal to 100. So 100 pointing to what? 100 value assigned to what? X. 100 value assigned to what? X. So now x is holding what? X is holding 100 or not? X is holding 100. Let's say x is holding 100. Okay, x is holding 100. So many times I told you that don't make any difference between even and x. Okay, x is a primitive variable, even is a what? Reference variable. In Java only two types of variable. In Java only two types of variable. One is what? Primitive variables, and one is what? Reference variable. Now these primitive variables uh, can be divided into what? Three types: static variables, local variable, instance variable. But in Java only two types of variable. One is what? Primitive variables, and one is reference variable. And both are same. Look at, both are same. This x is holding what? The value 100. This x is holding the value 100. This even is holding what? Employee object. According to the nature, the type of x is integer, so it can hold a integeric value. Here the type of even is employee, so it can hold employee object. The type of even is employee, so it can hold employee object. The type of even is employee, so it cannot hold student object. It cannot hold customer object, because the type of even is employee. Similarly, the type of x is integer, so it cannot hold string value. It cannot hold floating point value. Okay, so int x is equal to 100. Here x is pointing to 100. In the next line what you are doing? You are writing x is equal to 200. So of course the value of x will change, na, sir. The value of x, now earlier the value of x was 100, now the value of x becomes 200 or not? Same here. Same here. What is the issue? Okay, are you getting my point? What is the issue? Same here. I hope it's clear now. Look at, if you look at this one, employee even is equal to new employee, even is equal to new employee, both are same and same. E1 type is employee, X type is integer. E1 is holding employee object, X is holding 100. In the next line, E1 is equal to new object, X is equal to new value 200. So X was pointing to 100, X was holding 100, now X is holding 200. What is the issue? Okay, fine. I hope you are getting my point. Okay, now let's see. Let's say I'm going to give you another scenario. Have a look. Let's say instead of this E1 is equal to new employee, instead of this E1 is equal to new employee, if you have written something like this one, employee E2 is equal to new employee. Let's see. Employee E2 is equal to new employee. New employee. Okay, employee E2 is equal to new employee. Suppose you have written like that, employee E2 is equal to new employee. Assume that you have written like that. Then what will happen, sir? Then even is still pointing to 1000x, even is still pointing to 1000x, and here one new E2 will be created, and now the E2 will point to 2000x. Now E2 will point to 2000x because E2 is another variable. E2 is another variable. E2 is a what? Another variable. Okay. E2 is another variable. Just like same here, look at here. Here, if you instead of this x, instead of this x, if you write int y, if you write int y is equal to 200. So what will happen? The value of x will still 100. The value of x will still 100, and now this 200 value will come to what? Y variable. This 200 value will come to y value will become 200. X value is still 100. X value is still 100. Y value is 200 now. Here look at E1 is pointing to 1000x, still 1000x. It is pointing still 1000x because employee E2 is equal to new employee. You are assigning a new variable. You are taking a new variable E2. But if you pointing the object to the same variable, same E1 variable, of course, E1 will, which was pointing to 1000x, now it will point 2000x or not, sir? Yes, I hope you are getting my point. Now, let me go with the theory part. So for theory, let me copy. I'm not interested to type. Let me go for 8 p.m. Look at what is heap memory, sir? Have a look, all of you. Sir, it stores information regarding object and instance variables. It stores information regarding the object and instance variable. All the objects are created as a part of heap memory. So automatically all the instance variables are also the part of heap memory because instance variables are what? The part of object, when instance variables are created at the time of creating the object. Okay, at the time of creating the object, you remember this keyword. You remember this keyword we use for what? For representing the instance variable. This keyword we are used to representing what? Instance variable. Now this is only one heap area per jvm. Look at only these two memory. One is what? Method area, and one is what? Heap area. Method area and heap area are created only one per jvm. For a single JVM, there will be only one method area, there will be only one heap area. But there can be a multiple stack area, multiple threads, multiple stack area. Like main is a thread. We can create multiple threads in Java. So for a single JVM, there must be only one heap area, there must be only one stack area. Okay, there must be only one heap area, and must be only one heap area, one method area, one heap area. But there may be a multiple stack area. There may be a what? Multiple stack area. Okay, have a look. So it stores the information regarding the object and instance variable. All the objects are created as a part of heap memory. So automatically all the instance variables are also the part of heap memory. Now this is only one method, only one heap area per JVM. This is only one heap area per JVM. So remember, method area and heap area, these two are only one per JVM. Only one per JVM. And look at stack area. Have a look. For every thread, for every thread, sir, we have a separate topic called multi-threading. We have a separate topic called multi-threading. So in multi-threading, I will tell you that we can create multiple threads. And remember one point here, that our main method is also a thread. Our main method is also a thread. So for every thread, JVM creates a separate runtime stack. For every thread, JVM creates a separate runtime stack. Each stack is created as a part of what? Stack memory. Okay, each stack is created as a part of a stack memory. All the local variables are also the part of stack memory. Have a look. I want to show you one diagram. Sir, look at. Listen carefully. Sir, this is one stack memory. Okay, this is one stack memory. Okay, this is one stack memory. And now this stack memory is what, sir? Look at this stack memory is what? This stack memory is containing one particular thread. This stack memory is containing one particular thread. In Java, we can also create multiple threads. In Java, we can also create what? Multiple threads. These are the multiple threads. Let's say this is the thread T1. It is also a stack memory, sir. This is thread T1. This is what? Thread T2. It is also a stack memory. So that's why I told, look at if you read now, for every thread, this is a thread, this is also a thread, this is also a thread. So for every thread, JVM creates a separate runtime stack. Look at, this is a stack memory, this is also a stack memory, this is also stack memory. Okay, each stack is created as a part of a stack memory. All the local variables are also the part of a stack memory. And now look at one more point, sir. Each entry, let's say we always starts from main method. So here we have a main method, here we have a main method, and now let's say we have another method called m1. Let's assume we have another method called m1. Now let's assume we have another method called what? M2. Okay, so what I want to say you, each entry in the stack, this is like, this is one entry for main, this is one entry for m1, this is one entry for m2. Okay, so each entry in the stack is called stack frame. Like it is a stack frame, this is also one stack frame, this is also one stack frame. So each entry in the stack is called stack frame. Okay, and each stack frame contains three parts. Okay, each stack frame contains what's the three parts? Look at, these are the containing three parts. What are those three parts, sir? Have a look, sir. Local variable array, frame data, and operand stack. Local array, variable array, frame data, and operand stack. Have a look. Local variable array, frame data, operand stack. Okay, so this is one stack memory. Let me write. Sir, here you can write each entry in the stack is called stack frame. Each entry in the stack is called what's a stack frame. Okay, each entry in the stack is called stack frame. Okay, each entry, so this is one entry, this is another entry, this is another entry, and each entry is containing what? Three parts: local variable array, frame data, and what? Operand stack. Okay, let me save this. Stack information, stack internal information. Okay, so you got it. Yes, now have a look. So for every thread, JVM creates a separate runtime stack for this diagram. For this diagram, what I have created right now, it is an information for only one thread. It is one information, only one thread. Like that in multi-threading, when you learn multi-threading concepts, sir, in multi-threading, I will tell you, we have n number of threads. We have what? N number of threads, and main is a thread. Main is a what's a thread? Main is our main method is exactly a thread. Similarly, who is creating this main thread? JVM is creating a main thread. Okay, who is creating this main thread? JVM is creating a main thread. Have a look. If you want to look at, just give me 1 minute. Let's say thread a name. Thread a name. Sir, I want to know which thread is running here. Which thread is running here? Have a look. Which thread is running here? Sir, look at which thread is running here. Sir, thread is a predefined class available in java.lang package. It is a predefined class available in java.lang package. Dot current thread. Current thread is a static method. Current thread is a static method. Thread dot current thread. Current thread is a static method. And this is returning what? Current thread. Which current thread is running here? Which current thread is running here? Sir, I want to get the name of that thread. You remember method chaining, method chaining concept. This is method chaining, sir. Okay, thread name. Let me have save this program in Java. Let's say demo. I want to save thread name. Thread name dot Java. Now, when you run this program, we will definitely learn multi-threading concepts. Sir, in multi-threading concept, we will learn in detail. But when you run this program, which currently thread is running here? Can you tell me the current running thread name? Can you tell me the current running thread name? Which thread is currently running here? So when you run this program, have a look. B drive, CD Java, CD demo, CLS, Java C, thread name. When you compile and when you run this, or which thread is running here? Have a look. Main thread. So main is actually a thread. Main is actually a thread which can create multiple threads. Which can create what? Multiple threads. Main is exactly a thread which can create what? Multiple threads. Okay, so have a look now. Now let me go with the part we will discuss. Don't worry about that. So I hope up to here everything is clear. Okay, now let me copy this one. Okay, now have a look. Now we are going to run a program. We are going to run a program. Okay, we are going to run one or two programs. We will complete, sir. We will run, which will give you a very beautiful idea. What idea you will get? Have a look. What idea you will get, sir? First, this program will give you how to create heap and stack diagram. How to create what? Heap and stack diagram. How to create heap and stack diagram by using the same program. By using the same program, we can find out the output of complex to complex program. We can find out the output of complex to complex program. And the last one is what? How would I calculate, how would I calculate that how many objects are eligible for garbage collector? How many objects are eligible for what? Garbage collector. How many objects are eligible for garbage collector? Now here I want to give a small introduction about garbage collector. Have a look. Garbage collector means what, sir? Garbage collector means what? Have a look. Sir, let's say I want to show you. Let's say here I am going to create one object. Any object, sir. Let's say employee object. Employee E1 is equal to what, sir? New employee. Employee E1 is equal to new employee. One employee object I am going to create. Let me change the color. So one employee object I am going to create. Now what will happen? You know very well that one new memory location will be created, and that new memory location, that is the employee object, and it is referred by what? E1 reference variable. It is referred by what, sir? E1 reference variable. E1 is pointing to what? This one. This is what? Employee object. Okay. E1 is equal to new employee. E1 is pointing to employee object. Now in the next line, what I'm writing, have a look. I'm writing E1 is equal to what's a new employee. Again, same story. E1 is equal to new employee. Now what will happen in this case? Sir, in this case, what will happen? One new employee object will be created. Look at one new employee object will be created, because whenever we create object using new keyword, always it will create in a new memory location. And now this E1 which was pointing to this E1 which was pointing to first employee object, now this E1 will point to what? This employee object, and this reference is deleted. Okay, now this E1 is pointing to what? This employee object, second employee object. Okay, this E1 is pointing to what? Second employee object. And now look at this object. The first object is eligible for what? Garbage collector. The first object is eligible for garbage collector. This object is eligible for garbage collector. Now garbage collector can come and collect this object, because this object is not referred by any reference variable. Of course even was pointing earlier, but now even is pointing to what? Another employee object. So this object does not contain any references. This object does not contain any references has eligible for garbage collector. This object does not containing any references, hence eligible for garbage collector. Okay, are you getting my point? Okay. Or even instead of this one, if you write E1 is equal to null, E1 is equal to null, if you're writing here E1 is equal to null, then of course also in that case also this E1 is this object is this first object is what? Eligible for garbage collector. Okay, so let me show you practically now. Now This object is eligible for garbage collector. Now this object is eligible for what? Garbage collector. Correct or not? Now this object is eligible for garbage collector, because even is not pointing to this, even is not pointing to this, even is pointing to another object. Okay, have a look. So if you go to the small theory of garbage collector, have a look. A small theory of garbage collector, sir. It is an automatic memory management in Java. It is an automatic memory management in Java. JVM internally contains a component called garbage collector. It is responsible to delete the unused objects, or the objects which are not containing any references in the memory. Unused objects, or the objects which are not containing any references in the memory. So you can see, according to the diagram, if you look at the diagram, in this diagram, now this object is not pointed by any reference variable. So this is unused objects. This is what? Unused objects. So it is eligible for garbage collector. So if any object is not referred by any reference variable, that means what? It is a unused objects, and it can be eligible for what? Garbage collector. Garbage collector can delete this object. Garbage collector can delete this object, because in Java we have automatic memory management. In older languages like C++, okay, in C++, it is the responsibility of programmer to allocate the memory and to delocate the memory by writing destructor. But in Java, allocation is your responsibility, but memory deallocation is not your responsibility. Memory deallocation is automatically done by garbage collector, one part of the JVM. One part of the JVM. Now let me go to the program now. Okay, now let me go to the program. Have a look very carefully. Okay, let me go to the program. So let me just. So this program is very very important if you really want to know the internal architecture of how actually the programs are going to be executed in Java. Okay, and as I told you, the three benefits: how to create heap and stack diagram, how we can find out the output of complex to complex program. I will show very complex program. uh, of course its output is totally different. Its output you cannot evaluate until you know about this heap and stack diagram. Okay, if you have a good idea of heap and stack diagram, then only you can find out the output of that complex program. Otherwise it will be very very difficult. Okay, and how would I calculate that how many objects are eligible for garbage collector? So these three agenda we are going to solve by a particular program. Have a look. Sir, garbage collector, have a look. Look at, this is the first program. This is the first program. Okay, this is the first program. Have a look very carefully. Listen very carefully. Just have a look. This is the first program. Sir, if you look at this one, class customer, we have what? Private string name, private int ID. We have a customer class, two instance variable name and ID. We have a constructor. Look at all of you very carefully. We have a constructor. By using this constructor, I am initializing the instance variable value. By using this constructor, I am initializing the instance variable value via local variable. Now this dot name is equal to name, this dot id. Now you remember we have a setter method. I told you we have a setter method to set the value of id. A simple, what is the purpose of setter? To set the value of id. So whenever you call this set id method, have a look. Whenever you will call this set id method, and if you're passing 9, if you're passing 9, 9 is a what? 9 is a local, 9 will assign to local variable or not? The value 9 will assign to local variable, and it will initialize the instance variable, it will reinitialize the instance variable. So this current object, this instance variable value will become what? 9. This instance variable value will become what? 9. set id. So setter for setting the id and getter for getting the id, nothing else. Setter for setting the id, getter for getting the id. And here we have a class test. We have a main method, int val is equal to 100. We are creating customer object, customer e is equal to new customer. I'm calling this m1 method. I'm calling this m1 method and passing this e as a reference. Look at, I'm passing this e as a what, sir? This m1 method, and this e we are passing to what? This m1 method parameter. M1 method parameter. So this e is receiving what? The same object reference what I have created as a main method. And then we have some set id, customer objects, again set id, and then e get id. So let me give you the complete idea of this program by creating heap and stack diagram. Okay, complete idea. Just concentrate, you guys. Okay, have a look. So file, new, save, fine. So look at very carefully. Let me first draw the diagram. First of all, what's a, we have a heap memory, and then we have a what, stack memory. And you know very well that always we start with what, main stack. Always we start with what, main stack. And I'm going to give you a different color combination actually. For method I'm taking what, a blue color, and for heap memory and stack memory I'm taking what, red color. So blue color, and for heap memory and stack memory I always prefer red color. Okay, so this is created. So you can see here very carefully, heap memory is created, stack memory is created, and main stack is created. Okay, heap memory created, uh, heap memory is there, stack memory is there, and here we have a what, here we have a our program. So as you can see, we always start from what, main method. Line number 22, look at concentrate, just give 5 minute concentration, 5 to 6 minute concentration. Okay, it is a very important program I'm going to explain. Just give the full concentration. Excuse me. So sir, as I told you that we always starts with what, main stack, because our program execution always begins with what, main stack. So you can see here in the main stack, our first variable is what, val. Our first variable is what, val. So what I can write here, I can write here val colon 100. Val colon what, sir, 100. Our first variable value is what, 100. So val colon 100. Okay, and now after that you can see, listen carefully. After that you can see we are going to create one customer object. Sir, whenever we will create the customer object, always it will initialize the value of name and id. Always it will initialize the value of what, name and id whenever we create, because look at name and id, two instance variables we have. Name and id, two instance variable we have. So whenever we create the customer object, always it will initialize name and id. If you are not initializing, of course it will initialize with default values, with the default values by using what, compiler default constructor. But as you can see, we have already given the constructor here. Okay, so no need to worry. So look at customer is equal to new customer, and Ravi comma 2. Ravi comma 2 means what? The name value will be Rami and ID value will be 2. Name value will be Ravi and ID value will be 2. So look at what will happen here at 1000x. Look at very carefully, all of you. At 1000x, customer object will be created. Customer object will be created, and whenever the customer object will be created, it will always initialize with name and ID. It will always initialize with name and ID. Now here the twist is, here the what is the twist, sir? The twist is, look at here, the twist is what is the twist? Actually, id value is what, it is a primitive value, so directly we can write 2. Id value is what, it is a primitive value, it is a primitive value, so directly we can write what, 2. But name is still, name is again, it is referring to one object. You remember, a string constant pool. So name is what? Name is a reference variable which is pointing to Ravi in the string constant pool. And Ravi is what? A string object. Ravi is what? Ravi is a string object. It is not a primitive, just like 2 or 4 or some float value. Ravi is a string object. Ravi is a string object. Okay, Ravi is a what, sir? String object. Look at very carefully. You remember string constant pool diagram? Keep in your mind string constant pool diagram. In the string constant pool, Ravi will be created. Ravi object will be created, and that Ravi object is referred by what? This name reference variable. That means what will happen? Look at now. This name will also point to some address 2000x. This name will also point to some address 2000x, and in this 2000x, a string object will be created. A string object will be created where the value of name is what, sir? Where the value of name is Ravi. Okay, where the value of name is what? Ravi. Perfect, perfect. Name is pointing to 2000x. 2000x is where is the 2000x? 2000x is what? Inside the heap memory there is a part. Inside the heap memory there is a special area called string constant pool. Inside the heap area there is a special area called string constant pool where all the string objects are created, and those string objects are unmodifiable as well as not eligible for garbage collector. You remember, string objects are not modifiable, string objects are immutable, as well as not eligible for garbage collector. Garbage collector cannot delete string object. Garbage collector cannot delete string object, as well as it is immutable. You cannot change string object. Okay. So here everything is clear, sir. No problem. So this customer object is created, and this customer object you are assigning to this e variable. This customer object you are assigning to what? E variable. So now you can see, here we have a what? E variable. Here we have a E variable. E is a local variable, and this E variable is pointing to what, sir? This E variable is pointing to 1000x. This E variable is pointing to what? 1000x. This E variable is pointing to 1000x memory. Correct or not? Yes, perfect. Okay, up to here I think everything is clear, no problem at all. Okay, now what is next? Sir, next is, I'm going very slowly, step by step. You try to follow the step. Okay, you try to follow the step, because steps are very important. Now what you are doing, have a look. You're calling one m1 method. First of all, you are calling one m1 method. Sir, if you're calling one m1 method, first of all, what will happen? A new stack will be created. Okay, one, what will happen? One new stack will be created. Have a look. Here what? M1 underscore stack will be created, and whenever a new method will be created, M1 underscore stack, its color would be what? According to me, its color would be blue. You can have your own color, sir. So color is what? Blue. So new method is created. M1 stack is going to be created. Main stack, from main stack I have jump. The control is moving from main method to what? M1 method. Main method to M1 method. Now inside this M1 method, concentrate. Inside this M1 method, inside this M1 method, sir, the first variable is what? E. The first variable is what, sir? E. E is my first variable. Okay, E is my first variable. The first variable is what? E. Okay, the first variable is E. Now what this E will hold? What this E will hold? Look at what you are passing from here. From the main method, what you are passing? You are passing the reference of E or not? And what E is pointing? E is pointing to customer object. So the reference you are passing to M1 method, and this M1 method, this E type is what? Customer. The type of this E is what? Customer. Okay, and you're passing this E as a what? Customer type. So that means this E will point to same 1000x, because this E value you are sending here, this E value from the main stack, you are sending E value to what? M1 underscore stack. From main stack you are sending E value to what? M1 underscore stack. Correct or not? Yes. Now after that, have a look. After that, what you are doing? E dot set id. You remember I told you set id value, what it will do? It will just change the value of id. E dot set id. So from E means what? 1000x. Have a look. Look at this one, very important. So E means what? 1000x. So from 1000x you will get go to 1000x memory. Where is the id value? Here is the id value. The id value will become what? It will change from 2 to what? 5. The id value will become what? From 2 to 5. Okay, from this 1000x I am referring to this 1000x memory, and the value of id will become 2 to 5, because set id method will change the value of id. Okay, so now let me change the value of id. Now this 2 will become 5. Perfect. Now what is next, sir? Have a look. What is next? Have a look. What is next, sir? E is equal to new customer Rahul, comma 7. E is equal to new customer Rahul, comma 7. So again we are creating a new object. Just look at the right side. Just look at the right side. Again we are creating a new object. So we are creating a new object means what will happen, sir? Have a look. So again at 3000x one customer object will be created. At 3000x one customer object will be created. Okay, and whenever this customer object will be created, always it will create what? Name and id. Ah, sir, id is primitive, no problem. What is the value of id? The id value is 7. Look at the line number 33, left hand side. Id value is what? 7. And the what is the name value? Name value is Rahul. Have a look very carefully, all of you. What I want to tell you, sir, name value is Rahul. Name value is Rahul. If it is not Rahul, instead of Rahul, if it is Ravi, look at, if it is Ravi, listen my words very carefully, guys. If it is not Rahul, if it is Ravi, then what will happen? If it is not Rahul, if it is Ravi, assume that at line number 33, line number 33, this line number 33, E is equal to new customer Ravi, comma 7. Ravi, comma 7, sir, then JVM is not going to create a new Ravi object in the string constant pool. JVM is not going to create a new Ravi object in the string constant pool. The same Ravi, this name will refer to same Ravi object. That is what 2000x. That is what 2000x. Because once you remember, yes, once the once the string object is created, JVM is not going to create new string object. It will always check whether the string is pre-existing or not. If it is pre-existing in the string constant pool, JVM is not going to create the string object. The same old string object will be referred by new reference variable or variable new variable. Okay, new variable. So now this name is pointing to 2000x, because both name are same Ravi, but unfortunately here the name is different. We have Rahul. So once we have Rahul, that means what? The JVM has to create a new string object. So at 4000x one new string object will be created. At 4000x one new string object will be created, and it will hold what? Name value as a what? Rahul. Okay, perfect. Now look at the assignment part. So this object what we have created, what we have created, we are assigning to this object to what? E. We are assigning this object to what? E reference variable. We are assigning this object to what? E reference variable. That means what will happen? Look at the object we created right now, which will point to what? Same this E. So now this E which was pointing to 1000x, this E which was pointing to 1000x, now this E will point to what? 3000x. Now this E will point to what? 3000x. Perfect. Now this E is pointing to what? 3000x. Because the new object we have created in the same reference variable. New object we have assigned in the same reference variable E. And look at the line number 34, sir. E dot set id. E dot set id means what will happen? Look at, E is pointing to 3000x. So go to the 3000x memory. What is the value of id? The value of id is 7. Make it this id value as what? 9. Make it this id value as what? 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as 9. So let me make this id value as Okay, fine. Okay, now system.out.println e.getId. System.out.println e.getId. E.getId. System.out.println e.getId. Sir, e.getId means what? What you will get? E.getId. E means what? 3000x. 3000x ID value is what? 9. So in the output window, what is the first value you will get? The first value you will get 9. This is what? This is the output window. This is the output set output. So first output you will get what? 9. Because look at e.get id means what? E is pointing to 3000x. 3000x ID value is what? 9. Okay, perfect. Now this method is over. Look at very carefully. This method is completed. M1 method is completed. Sir, once the M1 method is completed, look at, this is the twist. Once this M1 method is completed, this M1 stack will be deleted from the stack. One M1 method is completed. Now this M1 method will be deleted from the stack. Okay, M1 method will be what? Deleted from the stack. This M1 method is not available right now. Now M1 is deleted. M1 is deleted from the stack. Okay, M1 is deleted from the stack, and now the control is what? The control will come back to here. Look at, control will come back to here. Now, in the interview room, listen very carefully. In the interview room, the interviewer will ask to you, sir, when the control will reach to line number 27, when the control will reach to line number 27 here, when control will reach here, when control will reach here, how many objects are eligible for garbage collector? How many objects are eligible for garbage collector? When your control will reach to line number 27, when your control will reach to line number 27, how many objects are eligible for garbage collector? Now you have to say how many objects are eligible to garbage collector. Have a look, I am going to tell you. So look at, this m1 underscore stack is deleted. This m1 underscore stack is deleted. Now you don't have this m1 underscore stack. This is deleted. Assume that it is deleted. Now from this main method, look at, you can only point to what? You can only point to 1000x. You can only point to what? 1000x. Okay, you can only point to what? 1000x. That means, that means from this main method, there is no chance, there is no way to point this 3000x. There is no way to point this 3000x. So this 3000x is eligible for what? Garbage collector. So now let's say if your garbage collector came at line number 27, if your garbage collector came at line number 27, so this garbage collector will check, okay, from this main method I can reach to what? 1000x. So 1000x I cannot delete. Okay, I cannot delete. 2000x is string object, I cannot delete. 4000x is string object, I cannot delete. Then it will see 3000x, sir. No one is referring to 3000x, sir. 3000x no one is referring. Look at, in the main stack, from the main stack I can refer only 1000x. 3000x is not referring. So this 3000x is happily eligible for what? Garbage collector. So JVM will take this 3000x, it will collect this 3000x object in the garbage collector basket, and it will carry it with itself, and this particular memory will be free. Because whenever you create an object, memory is occupied. So now this memory will be free, you can reuse. So how many objects are eligible for garbage collector? So here you can write 3000x object is eligible. 3000x object is eligible. Perfect. And now after this, system.out.println e.getId. Look at, from 1000x, from the main method, I can go to 1000x. 1000x ID value is what? 5. 1000x ID value is 5. So in the output window, what is the next point? What is the next thing you will get, sir? What is the next thing you will get? The next value you will get what? 5. That means in the output window, what is the output you will get? You will get 9 and 5. In the output window, what is, when you run this program, what is the output you will get? You will get the output as what? 9 and 5. Okay, perfect. Now someone is asking the question. No, Srinath. No. 3000x is created in the heap memory. 4000x is created in the string constant pool. 3000x is created in the heap memory. 4000x is created in the string constant pool. Inside the heap memory also we have different sections. Inside the heap memory, I have told you in the string constant pool, I told you inside the heap memory one special memory area is created in string constant pool. 3000x is created in the heap memory. 3000x is created in the heap memory. Have a look. So you remember, this is the memory, this is the string constant pool. Your 3000x object is created here as a part of heap. But your 4000x object is created what, sir? Your 4000x and 2000 objects are created what? Here only. Ravi and Rahul. So 2000x, 4000x, it cannot be deleted. It cannot be deleted. Okay, 2000x, 4000x, and here what's, sir? 1000x, 3000x. So this area is what? Garbage collector. This area is what? Eligible for garbage collector, but the string constant pool is not eligible for garbage collector. Okay, I hope everything is clear. Now let me run this program. First, let me save this. Let me run this. Whether we are getting the output or not. Cd dot dot cls cd garbage cls java c test dot java java test. Look at what output you are getting, sir. 9 and 5. Okay, 9 and 5 you're getting or not? Yes. So this is the program on garbage collector. Okay, this is the program on garbage collector. Tomorrow we will see one more program. Look at complex to complex program. You can see, look at, this is the very complex to complex program, sir. Very complex to complex program. Okay, you can see very changes, unlimited changes you are doing. Event.id, e2.id, we are assigning to event.id. So do one thing today, you practice. Okay, today you practice well. Okay, and so the tomorrow program will become very easy if you practice well.